as in the case of our estimating unknown things, here also we will estimate population variance using the formula x square is equal to 1 by n minus 1 sigma xi minus x bar the whole square, because sigma square is unknown. Therefore, this is a sample variance. Therefore, who is the best representative for the population variance? None other than sample variance. Okay. Therefore, sample variance you can take it. Therefore, in the normal case, when mu is to estimate mu, when sigma is unknown, so since sigma is known, we will use this function. Okay. Here are same thing. X bar minus mu, in the place of sigma, you will take ES. That's all. This is different from this, no? Here you are using sigma. Sigma is known. It's a constant. Here sigma is unknown. Therefore, this is a function of observations. This is a statistic. Now, the distribution cannot be normal, no? They are different. The distribution of this is called T distribution with the n minus 1 degrees of freedom. Okay, we have explained all the ideas about degrees of freedom. Now, you can see why the degree of freedom is important. I have given you the examples a number of times. Once again, I will give you that example. Okay. For example, if you take x is equal to sequence minus 4 to 4 with the 0.01. Okay, and curve dt x with the degree of freedom. I will take 10 with the tail, and x lim is equal to C brackets minus 5 to 5. Since I am going to plot so many curves, it is better to use different colors for different graphs. Yeah, this is T distribution with 10 degrees of freedom. You can see it is symmetric. Now, curve dt x comma 4 degrees of freedom. X lim is equal to C brackets minus 5 to 5. Okay, and color is equal to what color I can give? Let it be green. And I have to add it. Add is equal to true. Otherwise, it will be in a different graph paper. Okay, different graph paper. I select that alone and run. No error. I am lucky. You can see the shape is different. Therefore, if you take this portion, the area under the red curve and the area under the green curve, both are different. Probability is the area. Probability that A less than X less than B is area under the curve between A and B. Okay, therefore, for different degrees of freedom, you will get different shapes for the curve. Okay, different shapes for the curve and different shapes for the curve. Where is my program part? Where it is hiding? Yeah. Now again, if you look at curve curve dt x comma 8, x comma 8, x limit is equal to C bracket minus 5 to 5. Color is equal to violet. Add is equal to true. Okay. I select that alone, so that will be added.
Violet is spelling.
Yeah, violet is, correct. It is not seen. The error means it is saying that you are not careful. Okay, that is the meaning. That is the meaning of that. Now, please. Okay, now you can see here it is going somewhere. Okay, because violet and red, they are. This is the reason. My message is only this. That degrees of freedom is an important thing. Okay, that is why we have to specify it. Okay, T-distribution. Now, tables are available. To find the area, tables are available actually. Okay, you can get it for 5 rupees or 10 rupees like that. Okay, that is students T table. Students T distribution table. It is available. Okay, you can download it. These are the values given. Okay, that is not a beautiful table. You can take another table, critical values of the students T distribution. Yeah, tables are available. What is the meaning of this one? Here it is degrees of freedom. 1 degree of freedom, 2 degree of freedom, 3 degree of freedom, etc. Then up to 3.078 area is this. Up to 6.31 area is this. Okay. Up to 12.975. Up to 31.99. Okay. It is going up to degree of freedom 100. And after that it is giving infinity. Here you can see 1.290, etc. Okay. After a stage, the probability values are same for different values, no? Because it is approaching normal. Okay, where is our 0.975? Here you can see somewhere, here you can see 1.96 will be somewhere very near to 1.96 will be here. Yeah, 1.99998. Yeah, 1.96, you see, when the degree of freedom is very large. Okay, that table is also not good table. You can take T distribution step by step, students T distribution table. Yeah, it's a good table. Either you can use tables like this. Why you worry about table? Because now you are experts in R. Okay, to find QT. What is lower limits? 0.05. 0.05. Okay, degrees of freedom you give 10 degree of freedom. 10 degree of freedom. What is the meaning of this? Up to which point the area is 0.05, minus 1.81, etc. Now, if you want to verify is, you have to use PT function. PT minus 1.81 minus 1.81 2461. 2461 degree of freedom is 10. You should get 0.05. That's why it is an inverse function. It's an inverse function. 0.050000 etc. because some numerical techniques are used. Okay, therefore, if you know the value of P, you can get the value of T. If you know the value of T, you can get the value of P. Okay, now as before, here you can get the confidence interval. What is to be done? Probability that degrees of freedom is there. Degrees of freedom is there. Okay, suppose it is minus T alpha by 2. What is alpha? Suppose you want 95% confidence interval. Then 1 minus 0.95 is 0.05. Okay, therefore T alpha by 2 minus T alpha by 2 less than x bar minus mu by s by root n. It's a symmetric function. Therefore plus T alpha by 2, this is equal to 1 minus alpha. This is equal to 1 minus alpha. Okay, now you cross multiply and do all the exercise, you will get an interval. You will get an interval. Okay, now we will do one problem. We will do that problem taken from that article. Where is that article? Yeah, a sample of 16 10-year-old girls. A sample of 16 10-year-old girls. All those things are material for us. We don't want. Whether it is girls or boys, the method is same. Okay, 10-year-old girls gave a mean weight of 71.5, mean weight of 71.5, and standard deviation of 12 pounds. 12 pounds. Assuming normality, that is important. The parent, that I forgot to tell you, the parent population should be normal. Assuming normality, find the 90, 95, 99% confidence level for the population mean. Okay, now we don't want their help. We can take. Okay, what is the first part? First part is 90% confidence interval. 90% confidence interval. In all these cases, I suggest you to draw a curve. That is important, so that we will not make mistakes. Suppose this is T distribution. It is also a symmetric curve. Okay, 90%. Therefore, the middle part should be 90%. 90%. What's the remaining part? 10%. 5% should be here. 5% should be here. What is 5%? 0.05. 0.05. Therefore, what is the degrees of freedom? N is equal to, here it is, correct? Yeah, N is equal to 16. Because you need not worry about square roots. That is why it is taken as N is equal to 16. And X bar is equal to 71.5. And S is equal to 12. S is equal to 12. Okay. Now we want this one, 0.05. Okay. Therefore, degree of freedom, here it is N is 16. N is 16. Okay. but I think okay, n is equal to 16. Therefore, where is my r? Yeah. Therefore, here degree of freedom will be 16 minus 1, 15 degrees of freedom. Okay, and 0.05, and also you need QT, upper level. Upper level is 0.95. Yeah, 0.95. 0.95. 0.95. 15 degrees of freedom. 15 degrees of freedom. These two things you want. You simply, etc. Minus 1.75. That is enough for us. Minus 1.75. Therefore, probability that minus 1.75 less than x bar minus mu by s by root of n less than 71.5 minus mu by, 1.75 is 0.90. That is, this is the lower limit. This is the upper limit. In between, the area is 0.9. Therefore, probability that minus 1.75 into 3 minus 71.5 less than minus mu less than 1.75 into 3 minus 71.5 is 0.9. As before, you multiply by minus 1. Therefore, probability that 71.5 minus 5.25 less than mu less than plus 71.5 plus 5.25. That's all. That is probability that am I correct? Therefore, 90% confidence interval is 66.25, that is 76.75. 75. That's all. That's all. If you want a 95% confidence interval, here it should be 95%. The minimum is 5%. The balance is 5%. Therefore, 0.025 will come here and 0.025 will come here. Okay. Then you have to find QT 0.025. That's the only difference. 0.025 and 0.975. That's only difference. That's only difference. It is minus 2.13 and plus 2.13. You solve these things. That's all. Probability that you want more confidence interval means what? You want more wider interval, correct? Minus 2.13 less than x bar minus mu by s by root n less than plus 2.13. This is equal to 0.95. So that's how you solve it. 0.99 means 99 here. 1% is here. 1% is here. Point 0.005. Am I correct? Okay, that's all. Finished. 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 Okay. Another thing we want is a difference. Difference. Confidence interval for the difference of means. Okay. Suppose this is the experiment you are using. This is a result you are using from one experiment with the N1 observations. Okay. and you assume that the distribution is a normal with the mean mu1 and variance sigma 1 square. Okay, and another population is there from another setup n mu2 sigma 2 square, mu2 sigma 2 square. You are taking n1 observations here, x1, x2, etc., xn1. From here, you are taking n2 observations. Okay, let us make it different. y1, y2, etc., yn2. Here you are getting a sample mean x1 bar. Here you are getting sample mean x2 bar. Here sigma 1 square known, sigma 2 square known. We take that. You want to find what is the estimate for the difference. What's the estimate for the difference? Here you are not interested in mu1 and mu2. Here you are interested in the difference of mu1 and mu2. For example, you take some vaccine A for corona. Okay? And no, that is not a good example. Some medicine for tuberculosis, antibiotics for tuberculosis. It will take 180 days to cure it completely on an average, 180 days. Another one, it will take 170 days. There is a difference of 10 days. And you want to check whether that difference is significant or not. Okay, like that. Now here you consider x1 bar minus x2 bar. It is a variable, no? X1 bar is a variable actually. When you take different samples, you will get a different x1 bar. Okay, and when you take different samples for the second population, you will get a different x2 bar for the second population. Okay, therefore it is a variable. Therefore it has a distribution. The distribution is mu1 minus mu2. It is again a normal distribution with the mean mu1 minus mu2 and variance sigma 1 square by n1 plus sigma 2 square by n2. Because if these two populations are independent, if you take these two populations are independent, then this is a formula. Variance of x plus y is variance of x plus variance of y, if they are independent. Otherwise, you have to add a covariance step. Okay, x1 bar minus x2 bar. Now it is everything finished. Therefore, x1 bar, it is just an extension of the one variable case. Minus mu1 minus mu2. We have to remove our ego. We have to remove our ego and divide by our arrogance. Then we will become normal. Then only we will be a normal person. When ego is there, when arrogance is there, we cannot be normal. Okay, now it is normal. You take the variable and remove the, subtract the mean and divide by the standard deviation. Now you know the results. Probability that minus 1.96 less than that standardized normal, this is 0.95. Now you cross multiply and subtract x1 bar minus x2 bar, etc. And then finally you multiply by minus 1. You are getting a confidence interval for mu1 minus mu2. Something like this you will get finally. I need this result for testing for the equality of means of two populations. That is why I explained this here. Therefore, this AB is, A will get some value, no? X1 bar is known, X2 bar is known. Sigma 1 square is known, N1 is known, sigma 2 square is known, N2 is known. Everything is known. Only unknown things are mu1 and mu2. Okay, therefore this is the confidence interval for the difference of the means. Confidence interval for the difference of the means. Okay, you can think about a number of examples. Okay, suppose this is a diet you are taking to increase your weight. Okay, and this is the weight, increase in weight that follows normal distribution. This is some other weight you are applying to other group of persons, and this is the increase in weight. Here the average weight is 5.8 kilograms. Here the average weight is 6 kilograms. So there's a difference of 0.2 kilograms. Okay, therefore you have to find the confidence interval for the difference in gain of weights. Okay, I don't know the experiments in chemistry, etc. Therefore you can think of, you may have, okay, you may have two chemicals, chemical reactions, etc. In physics also you may use two metals for some reactions, okay, and you are getting different values for different experiments using different metals, and you want to see whether the difference is significant or not, like that, like that. Okay, now the same thing you can use for variance. Okay, now here you something different. N square by sigma square. N square by sigma square. Don't worry about the derivation. This follows chi square with n minus 1 degrees of freedom. This result we have to use. Chi square with n minus 1 degrees of freedom. Okay, and tables are available. Tables are available. You don't worry about the tables. Now you are experts in R. Okay, chi-square tables. Yeah, it is coming. Chi-square tables. So many tables are chi-square probabilities. Yeah, degrees of freedom here. Okay, for 1 degree of freedom, for this probability is given. The areas given across the top are the areas of the right of the critical value. Right of the critical value. Okay, up to what 100 degrees of freedom. But here there are gaps. You can use some interpolation formula, or you can take the average of these things. Average of these things. Okay, and other tables are also available. Other tables are available. Yeah, chi-square distribution table. Degrees of freedom here, probabilities here. Probabilities here. Or you can use our R. Our R. Our R. What is the QCHISQ? That's all. QCHIS, chi-square CHISQ. 0.025. Suppose degree of freedom is 10. Degree of freedom is 10. Okay. QCHISQ. QCHISQ 0.025, then 0.975. 0.975, degree of freedom 10. Degree of freedom 10. Okay. Then you will get a lower limit and upper limit. 3.24, 20.48. That is probability that 3.24 less than n square by sigma square less than 20.48. This is 0.95. N is known. N is known. S square is also known. Only unknown thing is sigma square. Therefore, you reverse it. 1 by 3.24. A less than B means 1 by A greater than B. That is probability that n square by 20.48 less than sigma square less than n square by 3.24. Finished. Finished. Confidence. N is known. In a particular example, n is known. Therefore, this is a constant. After simplification, you will get it as a constant. This will be getting as a constant. Therefore, that will be the 95%. Confidence interval for variance. Variance. Mainly you have to think about mean and variance. Okay. For applied statisticians, these are the two important things to take care of. Okay. But this knowledge is needed. This knowledge is needed. Okay. For ratios of variance, for example, sigma 1 square by sigma. Here we don't take sigma 1 square minus sigma 2 square because of theoretical reasons. It is very easy. That is why we will take this one. Last day I taught you F is N1 a chi-square variate divided by its degrees of freedom, another chi-square variate divided by its degrees of freedom, and if numerator and denominator, these two are independent, then this follows F distribution with N1 into degrees of freedom. N1 into degrees of freedom. Okay, now here, just now I taught you n square by sigma square is chi-square with n minus 1 degrees of freedom. That we will use now. That is n1 s1 square. n1 s1 square by sigma 1 square. This follows chi-square with n1 minus 1 degrees of freedom. n2 s2 square by sigma 2 square. This follows chi-square with n2 minus 1 degrees of freedom. Therefore, this one, chi-square by degrees of freedom. Therefore, n1 s1 square by sigma square, degree of freedom is n1 minus 1. n1 minus 1. Yeah. This one follows. This one follows. Chi-square with the n1 minus 1 is, I think, let me check. N square by sigma square follows chi-square with n minus 1 degrees of freedom. Okay. And here divide by n2 is 2 square by sigma 2 square into n2 minus 1. This follows F distribution with n1 minus 1 degrees of freedom, n2 minus 1 degrees of freedom. If you define this one properly, then you can take n1 minus 1 here, so that this will cancel. Here also this will cancel. Okay, you can take s1 square in two different ways. One with the denominator n1 and other with the denominator n1 minus 1. Okay, therefore it is not an issue. It is not. Therefore, this is the concept. Therefore, here again you can find probability A less than F less than B. This is equal to 0.95. From this means what? From R. What is to be done? QF. That's all. QF. QF. You have to give the 2 degrees of freedoms. 10 and suppose it is 10 and 15, you have to give. Here also you have to give 10 and 15. 10 and 15. Okay? 10 and 15. Yeah. 0.28, 44. This is a lower limit. This is upper limit. You substitute in this expression and so on. You will get the value of A. You will get the value of B. Okay? This is with this idea, you can take notes. Where is note? Yeah. Confidence interval. Finished. Confidence intervals for ratio of variances. It's better you read the theory part first, okay? And after that you can do that in ratio of variances by variance norm, confluence or ratio of two variances. Yeah. S1 square by S2 square. F distribution, that I think that is not a good note. That is not a confluence interval of variances stat online. I don't know whether it is a good one or not. Yeah. N minus 1 square by B sigma square. This is for one variance that we have seen. Okay. They have taken N minus 1. Okay. And they have given a colorful example. Okay. They are using mini tab. Yeah. This is the F distribution. If U and V are independent chi-square random variables R1 and R2 degrees of freedom, then U by Y R1 by A2. Properties for different degrees of freedom. For different degrees of freedom, this is a graph. This is a graph that we can easily see here. F is a positive variable. Therefore, you need to take 0 to 20. Let us take 0 to 20. I don't know whether it will go up to 20. Okay. Then curve DF. And X degrees of freedom 10 and 10. X limits 0 to 20. Let us draw the graph. And after that, we can change. If needed. Okay. Yeah. This is the graph for F distribution with 10 degrees of freedom. You can see it is not like normal, no? It is a positively skewed distribution. Okay. Now you add curve degrees of freedom 10 and 6. 10 and 6. Okay. You have to change the color, then only you can understand the difference. Okay. And you have to add it. Therefore, you have to request, then only the request will be accepted. Yeah. You can see, and you can do other things. 1 and 2. You can see the change. What is the color we can give? What is the magenta? I think the spelling is correct. That is 2. Yeah. Another one. And X 30, 30, and color purple. Yeah, you can see for different degrees of freedom, the shape is different. Shape is different means what? Area is different. Area different means what? Probability different. Okay, you can see all those things. Okay, this is about confidence intervals. Any questions? Any doubts? You can ask me. I am sure you will have doubts because we are taking these things in a class using at least 5 or 6 hours lectures. Okay, but you are all matured students. Idea is this: what is confidence interval? You are suggesting an interval with a certain level of confidence, so that that interval contains the parameter. That is all. That is all. Okay. Average height of students studying for final year PG program. You consider all the students in this world. All the students in this world studying for final PG program. That is a population. That is your population. Is it possible to measure all those students and take the average? No, it is not possible. You have to estimate. What is to be done? You take 100 students or 50 students like that. You will get a sample mean. That sample mean can be taken as an estimate for the population mean. Definitely, if you take another sample, some variation will be there. Another sample, some variation will be in the campus itself, in the Calicut University campus itself. If you take different samples from final year PG students, you will get different averages. In one case, it may be 160.3 centimeters. In another case, maybe 166. It will go like that. There may not be much deviation. If the sample is a random sample, you have to take random sample. Okay, and you are taking only one sample you are taking. You are taking only one sample and you are taking the average of that sample, and that is a point estimate. That's a point estimate. Okay, and you are not happy with that point estimate. Okay, I want to give a better idea so that you can suggest an interval 160 to 170 centimeters or 170 to 175 centimeters. Okay, that interval contains the height of the final year PG students, okay, with a certain confidence. Only in 5% of the cases, the height will be outside that interval. Similarly, you can think about weight. Here you assume that we are making a very crucial assumption. The parent population is normal. Okay? If the population variance is known, you can assume x bar also normally, x bar minus mu by sigma by root n is normally distributed with mean 0 and unit variance. Okay? If the population variance is unknown, then you can take an estimate for the population variance, then x bar minus mu by s by root of n, that follows a student's t distribution with n minus 1 degrees of freedom. You can use this in your examples. Okay, suppose you are taking some observations from different small insects. Okay, and you want to study some properties. Okay, if I am getting time, I will discuss central limit theorem also. Okay, that is one of the beautiful theorems. I usually say that theorem is the queen of theorems in statistics, because that is a basic idea for so many wonderful results. Surely I will do it. Surely I should do it, because it is it is actually a turning point in the inferential and the probability problems. Okay. Any questions?
No, sir.
It is just to motivate you to tell you that these have applications in theoretical science. Okay. Now itself I am copying all these things, and because otherwise I may forget. Today it is 27. Okay. So that you can add all these things in your paper. Okay. Usually you may use only point estimates. Okay. You know, you can have interval estimates with different levels, etc. Okay, and I am sure that final year PG students and MPhil students, this will be helpful. Okay, I understand that uh, these topics are some of these topics are asked for UGC, CSA or NET examinations. Okay, therefore, this will be helpful for you to prepare for UGC, CSA examinations also. Okay. If you have some idea, you can read books or articles or study materials, and you can develop the concepts. You can develop the concepts. Are you tired? Hmm?
No, sir.
Very good. Telling lies is also not a bad thing. Okay. Tomorrow we will discuss another wonderful topic, testing of statistical hypothesis. Testing of statistical hypothesis. That is also very useful for you. Botany, zoology, and other students from other faculties. Okay, and you don't worry, we will discuss all the things, and we will be a number of problems, and I know that rather than estimation problems, you are using testing problems in your dissertations. Okay. Nowadays, don't worry about the literature articles available. So many articles are available. Okay, and for basic ideas, Okay. Now these are the only facilities we can make use of nowadays, because we cannot go to library now, we cannot go to university, and we cannot take books from library, etc. But some of these type of articles will give you some basic ideas, and also some study materials from IGNO. It is freely available. Okay, in Jnana Ghosh, something like that. That is statistical inference. That is also a wonderful source of reference. Jnana Ghosh. Or Jnana. Let us try. Department of Education PhD coursework, I don't know. Yeah, Jnana Ghosh. Statistical achievement manageable advanced social Jnana Ghosh, not Jnana Ghosh. Jnana Ghosh. That's inference. It is freely available. You can download this thing. URI appears in collection book for research process. Unit 17 PDF. Yeah, statistical inference, concept of statistical inference, statistical estimation, concept of hypothesis testings. It is by IGNO units, okay, the national universities. Okay. I am giving you so many things. Hypothesis testing that we will discuss tomorrow. Okay, 21 pages, only 21 pages are there. It is only one chapter. You can get other chapters from, it is block 4 research process. Yeah, research design, research plan. It is good for your MPhil paper, I think. Research methodology paper, no? Research design. Okay. Nowadays, research methodology is a paper for MPhil. What is case studies? What is content studies? Cross-sectional studies, longitudinal studies. Okay. All those things are discussed. And these things are, I am sure, written by university professors. Therefore, the contents will be good as well as error-free. Error-free. And they are giving some reference also. Yeah. Research methodology, a step-by-step guide for beginners, etc. Okay, now it is 13:03. If you have some questions, you can please ask me, or you can even send to my mail. No problem. Surely I will reply to those questions. If you don't have any questions, you please permit me to wind up. Hello.
Okay, sir.
Because I am sure I was running first because I have to discuss correlation, regression, logistic regression, testing, and non-parametric also. Okay, in coming 4 days. Okay, therefore, I have to touch at least all those things. And I have to do in testing, I have to do some problems. In regression, I have to do more problems. In correlation also, I have to do 1 or 2 problems. Therefore, we need more time to discuss those things. Okay. I have already sent the notes to Shahin sir. He will share with you. Any questions? Any comments? Okay. Thank you, Ashifa. Thank you very much. Okay, then with your permission, shall I wind up? Shall I leave?
Thank you, sir.
Thank